Let's talk about a crucial detail in plastic design, the draft angle. It's a slight taper, just a degree or two, added to the sides of a part. Instead of perfectly vertical walls, we tilt them out ever so slightly. Why? It's all about injection molding. We inject molten plastic into a steel mold, let it cool, then need to get the part out. Without a draft angle, the part sticks, scrapes, or even breaks during ejection. Friction and suction become your enemies. That tiny slope lets the part release smoothly, protecting both the part and the expensive mold. No draft? Expect drag marks, damage, and costly delays. A draft angle is the difference between flawless production and a manufacturing headache. It's a small design choice that saves time, money, and ensures every part is perfect. In short, it's a fundamental rule of plastic design, the unsung hero that makes mass production possible. Ever notice how plastic cups stack and unstack so easily? That's the draft angle at work. The slight taper that lets them slide apart with no effort. If the walls were perfectly straight, they'd stick, screech, and even break. In factories, zero draft parts are hard to eject, leading to bent rims, drag marks, and ruined products. Draft angles make ejection easy, keeping parts flawless and surfaces pristine. They also protect the mold, which is expensive and must last for thousands of cycles. Without draft, friction wears down the mold, causing costly repairs and downtime. With proper draft, production is faster, smoother, and more cost-effective. It's not just about looks, it's about efficiency and reliability. Draft angles save money, time, and headaches at every step. They're the reason mass-produced plastic parts look and function perfectly. It's a simple tweak with massive impact. That's why draft angles matter. So how much draft do you need? For most smooth parts, start with half a degree to 1 degree. If you can add more, 2 or 3 degrees, even better. Ribs and bosses need draft too. Aim for at least 1 degree. Internal features like slots or holes, go for 3 degrees or more. Every surface that moves parallel to the mold's opening needs draft. Don't just draft the outside, check every wall, rib and boss. Think like the machine. How will this part come out? Following these guidelines means fewer problems and better parts. It's about building manufacturability into your design from the start. Draft isn't optional, it's essential. Texture and part depth change the draft game. Textured surfaces, like a grippy tool handle, need more draft. The rougher the texture, the more the part wants to stick to the mold. Rule of thumb: for every 0.001 inch of texture depth, add 1 to 1.5 degrees of draft. Light textures might need 2 degrees. Deep leather grains could need 5 or more. Deep parts also need extra draft, even if they're smooth. The longer the wall, the more friction during ejection. Shallow parts can get by with less, but deep buckets or tall enclosures need 3 degrees or more. It's all about balancing design with manufacturing reality. More texture or depth, add more draft. It's a trade-off, but it ensures clean, undamaged parts. Always adjust your draft for texture and depth. Here's the most important advice. Talk to your toolmaker. They know what works for their machines and materials. Before finalizing your design, get their feedback on draft angles. Sometimes a small tweak makes all the difference. Draft angles are tiny details, but they make or break your project. Get them right, and you'll have smooth production and perfect parts. Get them wrong, and you'll face delays, defects, and extra costs. Success in manufacturing is built on these small, smart choices. Next time you see a plastic part, spot that subtle slope and appreciate the thinking behind it. Draft angles, the invisible key to making great products.